Okay, diagram shows what happens before. After collision, A moves with velocity 2 meters perpendicular to the line of centers. So A moves up there at 2 meters per second, and B moves with velocity 2 meters per second and an angle of 45 degrees. So it can either go this way or this way. I'm going to put it this way, like so, because this one's weighs 2m, it's likely to bash it this way. So it's that bit is 45 degrees to line of centers, and that is also moving at 2 meters per second. And it says that E, which is separation speed over approach speed, is 2/3. And I've got to show something that, right, well, first off, I'm going to start with looking at this bit here, and the initial velocity this way, because there's no impulse perpendicular to the lines of centers, so therefore the initial momentum must equal the final momentum, and since the mass of this one doesn't change, the initial velocity in this direction must equal the final velocity. And so I'm going to be looking upwards for A, and that says that A sine alpha equals 2. And I can do the same thing over here for B, again looking upwards, that says that B sine beta, that's that bit here, B sine beta equals 2, and that's going to be sine 45. And sine 45 is root 2 over 2, so that will equal root 2. So it's done the first bit. Now I'm going to look horizontally, and therefore I'm going to have conservation of momentum. And I've got total initial momentum. Don't forget, momentum is mass times velocity. So I need to have its mass for the left one is 2m times by A cos alpha. And then don't forget, momentum, direction matters. So it's going to be minus mass times the velocity, which will be B cos B or cos beta, and that's the initial momentum, and that's going to have to equal the final momentum. Final momentum of this one in the left-right direction will be 0 plus the mass times by, and this bit will be 2 cos 45, m times 2 cos 45, and I can then obviously cancel through the m's, and this will say that 2a cos alpha minus b cos beta equals 2 times root 2 over 2, that is root 2. So I've done that bit. Now I haven't used the E bit yet, so let's use the E bit. E equals separation speed over approach speed. And so the separation speed will obviously be the speeds they move apart, which will be 2 cos 45. And that will equal the approach speed. This one's coming in at A cos alpha. So we got A cos alpha, and then plus this one's coming in at B cos beta. So B cos beta, and that's E, and we're told that E equals 2/3. And so what I'm going to do is times everything through by the bottom bit, and this will give me, that's 2 root 2 over 2, so that's root 2. It's times by 3, so that's going to be 3 root 2 equals 2 lots of this bit, so that'll be 2a cos alpha plus 2b cos beta. So I've got that, and that's actually pretty similar to what I've got over here. So this is just going to be simultaneous equations now. So I'm going to write this the other way around over underneath it. So I've got 2a cos alpha plus 2b cos beta equals 3 root 2. That's that bit. And the question asked me to find out what A cos alpha, so I need to get rid of this bit, so I'm going to take this one here and I'm going to multiply it by 2 to get 4a cos alpha, or it's not plus, minus, multiplying it by 2, so minus 2b cos beta equals 2 root 2. And now I'm going to get rid of the betas, the b cos betas, so I'm going to add them, and that will give me 6a cos alpha equals 5 root 2. Therefore, a cos alpha equals 5 root 2 over 6, which is what it wants to be. And then I need to find what's b cos beta, and I can do that from here. So this one will say that b cos beta equals 2a cos alpha minus root 2. So b cos beta equals 2a cos alpha, so that'd be 2 lots of this, so that'd be 2 times by 5 root 2 over 6 minus root 2, and so that's 10 root 2 over 6 minus 6, that'd be 4 over 6 root 2, which equals 2/3 of root 2. So I've done that bit, and then finally part 2, find the values of a and alpha. So I need equations with those in there. Well, I've got one here, so I've got a sine alpha equals 2, and have I got any other things? I've got one here, so I've got that, which is a cos alpha equals 5 root 2 over 6. Well, it's easy. I'm just going to divide those two. That will give me tan alpha equals 2 over 5 root 2 over 6. And that on my calculator gives me 6 root 2 over 5. And therefore alpha equals tan to the minus 1 of that, which is 59.49104,113 degrees, roughly. And if I put that back into here, then I get a equals 2 over sine 59.49, etc. And that gives me a equals 2.32139846, or 2.3223 significant figures. And hope you can follow the layout through that. Just like some of these linking words to say what I'm doing. I said I was going vertically there. I said I was going vertically here for this one. I said I was looking horizontal for conservation of momentum. I've put down E equals separation speed over approach speed. I've tried to make it clear, although I've tried to keep it also onto just one screen. Hope that's clear, but that's question 5 done.